Hi, ninth graders. Sorry there's a little bit of noise in the background. That is my dishwasher and my family. But for those of you who are catching in here, this is page 82, and I asked you on your module to fill in this whole page to get all the tables filled in. Now I know some of you probably didn't know how to get started filling your tables in, so if you needed that extra help, I'll show you how to do the first table and then you can pause the video and fill in the rest on your own. So this first table is following the function y equals 3 to the power of x. So if I've got all these x values on the left side of my table here, I'm going to find the y values by taking that equation, y equals 3 to the power of x, but instead of just leaving that x there, I'm going to use the x value that I was given. So 3 to the power of negative 3. And I'm actually going to be able to do that for each of these, plugging in the x value that I'm given on the far left. So y equals 3 to the negative 1, y equals 3 to the 0, y equals 3 to the 1, y equals 3 squared, and y equals 3 cubed. All right, so the best way to do these, some of you might have your exponents able to do in your heads. Others of you might be relying on a calculator, which is fine right now. Couple options for a good calculator. Cell phones have good calculators. The way to get some of the extra functions, like possibly exponents, you might need to unlock your screen and turn it sideways, because when you turn it sideways, you get a whole bunch of extra features on your calculator. Hopefully you already knew that. The other options, we've talked about these in class. Oh boy. One of them you can get to on your Chromebook. It is desmos.com. That is a graphing website, but they also will calculate all these things. It's an awesome tool, and that's actually the one that you're allowed to use on the ACT Aspire test. Another good calculator option, if you have an iPhone, is TI, and I don't know if there's a dash in there, but it's TIQlator. I don't think it's .com. I don't know why I'm writing that, so I'm going to turn that into a backslash. That is a good one for iPhones. And the one for Androids is actually the one that mimics our classroom graphing calculator exactly, and it is WABBITEMU. That is a good one for Androids. So if you are still looking for a good calculator option, one of those three is great. But let's assume that you've all got a calculator you can use. When you're doing 3 to the power of negative 3, you do get a decimal, but I want to remind you what the fraction form would look like. It would be 1 over 27. Y to the negative 3 squared, or y equals negative 3 squared would give us 1 over 9. 3 to the negative 1 would be 1 over 3. And as you notice, remember with those negative exponents, it's just like doing a positive exponent, but it brings the value of that positive exponent to the denominator. So that's how we account for a negative in the exponent. 3 to the 0 power is 1, 3 to the first power is 3, 3 squared is 9, and 3 cubed is 27. It's poor handwriting because I am writing from a weird angle. All right, so now to get that thing graphed, you're using this as an ordered pair. So the coordinate negative 3 and 1/27. I start at the origin and I go to the left 3 spaces, and how far up is 1/27? That's a really small distance. It's gonna be like barely above 0. I made that way too high because the dot that I made looks like 1/3. So let's do the next dot. Negative 2, 1/9. I go to the left 2 spaces up to 1/9. Notice these are both really low, almost to 0, because 1/9 is like nothing. If you're thinking about 1/27, that's like taking a pizza, cutting it into 27 pieces and taking one of them. That's the worst slice of pizza on the planet. 1/9 is a little bit better, cutting your pizza into 9 slices and you get one of them. But 1/3, that's what we're talking about when we want to slice a pizza. 1/3 is going to be a third of the way up to 1. When you go to 0, 1, it's right here. And then to the right 1 space, up 3, right here. To the right 2 spaces, up 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And when I go to the right 3, 27, there's no way 27's fitting on this graph. So when you connect these, I want you to be careful. Please make sure that your line curves And notice it never hits 3 because I don't have 27 on my graph. It can't cross that 3 line. And also, mine goes up a little bit too high, but these should never be dropping below 0, because if you keep going smaller and smaller and smaller, it's never going to get to 0. Because you're always just, instead of multiplying by 3, you're dividing by 3. And if you keep doing a third of the distance, you never actually pass 0. So this is what your graph should look like for each of these. If you haven't already, take a second to pause the screen and fill in the rest of the paper as far as the tables and the graphs go. I've got all the tables filled in. I'm just gonna get these graphs filled in really quick. And I know there's all this other information. We'll talk about that in just a second. So over on this, oh, I'm zoomed in. Yep, there we go. Okay, on this paper over here, I've got -3 and 1/64. Again, a really low dot. -2, 1/16, really low. -1, 1/4. 0, 1, 1, 4, and then 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, conveniently at the very top. All right, let's see how well I can connect these dots. That one was far steeper than the last one. All right, I did this one already. We've got our table there. And then this one, notice it doesn't drop as quickly as the other ones because it started at 5 in the middle for the y-intercept. All right, we've got -3 up 8. 1, 2, 3, 4, 5, 6, 7, 8. -2 up 4. -1 up 2. 0 up 1. 1 up half. 2 up 1/4, 3 up 1/8. So this one looks something like that. Don't ask me why it curved up, because I've got poor handwriting. It should still be like edging out in a flat line almost. Okay, the next one, -3 up 24, not gonna fit. -2 up 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right here. -1 up 6, 1, 2, 3, 4, 5, 6. 0 up 3, 1 up 1.5, 2 up 0.75, 3 up 3.75. And this one connects like this. And for our last graph, -3 up 0.1875. If you're wondering why I switched to decimals, it's because I didn't want to deal with the fractions that were there. Yes, we are supposed to use fractions when possible, but on something like this where all I'm trying to do is get them graphed, fractions or decimals were going to be an easier way for me to understand where they went on the graph. I don't know, maybe Mr. Bodley would say something different, but you can ask him if you are in his class. But in my class, I'm okay if this table has decimals. And I'll just speak for Mr. Bodley. He's cool with it, don't worry. Okay, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, here's our last graph. So yours should look like this as well. And now we are going to be mathematicians. We are going to figure out what makes these graphs similar and what makes these graphs different. And we're going to answer these 4 questions that go with every one of these graphs along the way. So we're going to start by talking about that thing called a change factor. Now, a change factor is what is being multiplied. Now, it's kind of a loaded question because each of these has a different thing that's being multiplied, and it depends on which direction you're looking at. So actually, before we start on the change factor, I want to talk about what a y-intercept is. You've all seen a y-intercept on a linear function before. On an exponential function, it's really just where it crosses the y-axis. There's nothing new or fancy there. Now, we have a couple different ways of talking about the y-intercept. Sometimes we'll just call that y-intercept 1. But today, I'm going to show you the more formal way to talk about it. A y-intercept is a point, so we can write it as an ordered pair. So we would say 0, 1. And I'm actually going to go through each of these y-intercepts, and we're going to find them all. So look back at number 2. This has a y-intercept right here, and that is also at 0, 1. Number 3 has a much higher y-intercept. That is at positive 5. So my y-intercept over here, 0, 5. Number 4, my y-intercept is at 1. So I say 0, 1. Also, hopefully you're noticing those y-intercepts show up in the table as well. Down here on number 5, my y-intercept is 3 spaces up. So I would say 0, 3. And number 6, my y-intercept, it's at a decimal. It's okay. It's not the end of the world. That's 1.5 spaces up. That's going to be 0, 1.5. For all my fancy people out there, you could also say 0, 3 halves. But like that's just presumptuous. Like who says 3 halves? You don't have 3 halves of a slice of pizza. Though that would be really nice because, well, 3 halves of a pizza. All right, now I'm thinking about pizza. Okay, let's talk about change factor. When you can see where it starts, your change factor is always what you need to multiply to move it to the right. So if this starts at a y-intercept of 1, my change factor is how I get from 1 up to 3. And then from 3 up to 9. So you're looking for the multiplying pattern on the right side. Now to go from 1 to 3 to 9, I'm multiplying by 3. I want you to write that on your paper, times 3, and I want you to circle it on the right side. Now, on the right side we multiply by 3. On the left side, you drop. It's not multiplying by 3 on the left, it's actually multiplying by the inverse of that. You're gonna multiply by the reciprocal, which would be 1/3. So you get to see this weird little pattern thing going on, where on the right side it's multiplying by 3, or dun dun dun, 3 over 1, and on the left side it's multiplying by 1/3. If you look at number 2, starts at 1, jumps up to 4, and then jumps up to 16. Here, it's multiplying by 4 on the right side, and here, on the left side, when it drops down to 1/4, 1/16, 1/64, our multiplier is 1/4. So when we're doing this, our change factor on these is always what it multiplies to get in the positive direction. So my change factor for number 1 is 3. My change factor for number 2 is 4. I want you to take a second, try to find the change factor for everything else on this paper. I promise it'll help you if you try this. So, pause the screen for a second and push play again once you found the rest of the change factors. All right, hopefully you listened to me there. If not, I will never know. Isn't that so fun? Yay, online learning. Okay, on this next one, it starts at 5, it jumps up to 10, it's multiplying by 2, and on the other side, multiplying by half. I promise there's a reason I'm drawing both of these on there. I'd like you to get into the habit of doing that. I want to see it on every single graph that you draw on your paper. Our change factor for number 3 is 2. Over on this next one, this is weird. Okay, let's say that I didn't have the table. How the heck can I see what's going on the right side? I don't like guessing because I'm usually wrong when I guess. So looking at the left side, I jump from 1 to 2 to 4 to 8. I can see that on the left side it's multiplying by 2, and that is not my change factor. I hope you didn't write down 2 for your change factor, because remember, our change factor always goes on the right side. That's why we circle it over here. So if it was multiplying by 2 over 1 on the left, then on the right side I'm going to multiply by 1 over 2. All right, let's look at the next one. Here, same pattern where I start at 3 and I go up to 6. It's multiplying by 2, which means my change factor is 1/2. So both of these have a change factor of 1/2. On the last one, starts at 1.5, jumps up to 3, jumps up to 6. That is multiplying by 2. That is my change factor. The other side is multiplying by 1/2. So then, as we are mathematicians, what we talk about next is, where do these numbers come from? How can these help us in regular everyday math? Well, if I look at number 1, my y-intercept here was 1. My change factor was 3. Look back at the equation. How did I get 1 and 3 from that equation? Over here, my y-intercept was 1, my change factor was 4. How did I get 1 and 4 from that equation? Now those ones weren't as helpful as number 3 is. On number 3, my y-intercept is 5, and my change factor is 2. Where the heck did 5 and 2 come from in that equation? You're looking for a pattern, mathematicians. Here, 1 and 1/2, there's my equation. 3 and 1/2, there's my equation. 1.5 and 2, there's my equation. So hopefully at this point you're noticing that the change factor always shows up underneath the exponent. So I'm going to twist my paper sideways, and I'm going to say y equals, and I'm going to leave a little space here, but then I'm going to say that it's always multiplying by the change factor to the power of x. So that's always showing up because 1/2 is underneath the x, 2 is underneath the x, 1/2, 2, 3 is underneath the x, and 4 is underneath the x. Now the y-intercept, when you're looking at problems 3 and 5, that y-intercept shows up after the equal sign before the multiply. So where the heck does it show up for problem 4 though? Because that 1 is not showing up here unless, dun dun dun, remember how there's always the ability to multiply by 1? That's what's happening here. When there's only a number to the power of x, you're really supposed to multiply by 1 in front of that mentally so that you can figure out what the y-intercept is. So the y-intercept was there all along. Oh my goodness, what a fun ending to that story. So you're always going to follow this format. Y equals the y-intercept times the change factor to the power of x. Now, that is going to help us graphing. I hope you all wrote that down. If not, shame on you. If I wrote it down, you should write it down. Okay, I'm going to draw an arrow over here, and I'm going to write a little note to myself that's going to help me speed up this process. So this is what's so cool about this process. That y-intercept is where I can start. So I'm going to say start at y-intercept. We're always going to start with a dot at the y-intercept. And then after that, you are going to use change factor on right side. And hopefully that makes sense from the picture. Let's see. What else didn't we talk about here? Oh, I know, this is going to be a long video. I feel it too. Domain and range. Hopefully you remember something about domain and range. If not, I guess welcome to the club. Domain, that's how far your graph goes to the left and how far your graph can go to the right. So since this graph points to the left, that's going on forever. The way that we write that's going on forever to the left is by opening parentheses and writing a negative infinity. Now to the right, it's going up, but you'll notice we can always plug in bigger x values, which means my x values always go to the right. So this can go to positive infinity. And that is actually true about every single graph on here. Every graph can go to the left and to the right forever. So all of these are going to have domains of negative infinity to infinity, negative infinity to infinity, negative infinity to infinity, negative infinity to infinity, negative infinity to infinity. Our domain is limitless in both directions. We can plug in any value of x. But our range is where we have issue. Our range is not allowed to go below 0, but it can go upwards to infinity. So here's how we write that. We say the lowest it can go is 0. Notice I left an open parenthesis because I don't want to touch 0. It can just get really infinitely close, and it can go up to positive infinity. So all of my ranges are going to be 0 to infinity here. 0 to infinity, 0 to infinity, 0 to infinity, and 0 to infinity. All right, here's the good news. I know this was kind of a long video, but I'm gonna now show you how to do this in like half the time. Don't you always wish that like I'd show you that first? Well, tough beans, you get to do everything the difficult way first. So I would like you to flip to page 83. flip on the back side. All right, on page 83, you've got the same exact number of graphs that you had on your homework. And I'm gonna expect you to do these way faster. Here's how. Because all of these are going to follow the format we talked about on the last page. You're gonna start at the y-intercept, and you're gonna multiply by the change factor to the power of x. I wrote that really small. But what does that mean? Well, look at number 7. The y-intercept, that's the thing in front. So my y-intercept on number 7 is 0, 2. Okay, so I'm gonna put my first dot to the right 0 spaces, up 2 spaces. Then my change factor is the whatever value is underneath the exponent. So here, my change factor is 3. Now remember, your change factor always shows up on the right side. So over here, I'm gonna say times 3. That's my change factor. Now, if it's multiplying by 3 over here, then that means on the other side, it's going to be shrinking by 3, which means multiplying by 1/3. So now if I started at 2, I know that 2 times 3 is 6. So my next dot is not going up 6 spaces from 2, it's just going up 6 spaces in general. So I started a dot at 2, and then I start with my next dot to the right 1 space and up to the number 6. 6 times 3 is 18. Best part about being on a video is like nobody can correct me even if I make weird math mistakes, so that's fun. Now if we go back to 2, 1/3 of 2 is, I don't know, like 0.7, yeah, it's gonna be like right here, 0.6 repeating. And then these are going to keep shrinking by 1/3, and you can calculate these exactly on your calculator, but as you notice, these decimals are going to get very, very small. Notice I drew in every decimal possible, even though they all pretty much look like they're at 0, they're just getting infinitely closer to 0. Go ahead and connect these. Try to be neat with your connecting. Even if you have bad handwriting, well, if you have bad handwriting, you should probably change that about yourself. Practice it, you can get better at it, I promise. That is how you're going to graph these. You have 5 more problems, and this is actually your math homework tonight. So congratulations, I did one of your math homework problems for you. Try the rest of these, that shouldn't take you very long. We will see you tomorrow, 9th graders.